Okay, so we're going to learn about how to add a node on binary tree. Well, these are set and done, right? This looks so complex and it looks so complicated, but I'll be honest with you. The concept, we understand the concept, it got a lot easier. It's just like divide and conquer. Okay, so let's go through the code and see how can we add a node on the binary tree. Okay, so first thing first, let's just write the functions right here, and functions will take uh, value, right? So that value will be added on the binary tree, and as you can see, the binary tree have on the left some data that is less than the root, and then on the right, that data greater than the root. So that's how we're going to divide and sort the data into left and right. Okay, so left, uh, smaller number, right, bigger number. So first thing first, we have to create a new node, which is right here, and then new, call new, and then node pass value. So we just created a new node. Okay, so now let's check if the root is empty. Let's check if root is empty. If it's empty, then we can just the root, add the new node there, and then return the tree, right? And that's it. So if it's not, if the root is not empty, then we have to traverse it. So that'll be let current node, and then this dot root, right? And then we can traverse into that current node. Okay, so now we're gonna traverse, so it will be true. So when we traverse into the node, we will have to look left and right, and then check if we can add it in each whatever position that it fits. So first thing first, we have to the challenge itself asks us to define some kind of flag that we can show it to the indicate that this data is already added, right? So in this case, undefined is the flag that we want to show it. We want to flag when the data is added and successfully added. So we will check if current node dot value is equal to value that we just passed. If it's true, then we will return and then undefined. So the value is added, so we don't have to traverse again. So otherwise, we will check the left. So if the current node dot left is no node dot left dot value, well, we can do it like this. Value is less than current node dot left dot value, then we will have to traverse to the left. Makes sense? And so we will check if current node dot left is empty. If it's empty, then we will just return this, and we will add current node dot left equal to new node. So once we add the new node to the left, then we will just return the tree, and that's it. We don't have to traverse it. So that's what we were saying right here. So else, so automatically it failed if it's greater than the current value, right? So then we will have to traverse on the right. So current no current no dot right. Okay, and check if current no dot right is empty. So if it's empty, then we will have to add it on current node dot right and new node. So we're going to add the new node right there. And if it's empty, then we will add there, and if it's not, we will traverse to the right. So let's check if this statements are true, and if it's true, it will work. Okay, control and enter. Okay, something is not work correctly. Yep, let's try and figure this out. Okay, so it was a mistake on this right here. If we look at, so yeah, we missed the R. So yep, let's try and control and enter, and it worked correctly. So that's the solution. And yeah, if you look at the tree right here, what we just did was say so basically we look at the root on the top right here, and if it's empty, we just add the number and return the tree. If it's not empty, then we have to take the root, and then we traverse through the root, the tree, check if the value is added successfully, and if it's added successfully, we just return undefined, and we escape from the loop, while loop. If not, then we check the value. If it's less than, in this case 3, if we're trying to add 3, then we traverse on the left, and if the left branch is empty, we add the new node and return the tree. If it's not empty, we traverse and then move on to the left or the right branch. Similar to any new data that we're trying to, or value that we're trying to add, it will do it for these branches, right? And that's it for the binary, how to add data in binary tree.